All right, today we're talking about reducing, multiplying, and dividing rational expressions. We're also going to end up stating the domain of the rational expression, which that should actually be a review from last unit, talking about the domain. All right, so on example 1, you can't, see how these x squares right here? You can't cancel those out. Anytime you have subtracting or adding, everything has to be exactly the same, the whole statement, in order for you to cancel it. So in this case, if you were just to look at this right now, you couldn't cancel anything. All right? But if we factor it and you have like a parenthesis that matches one on the top with one on the bottom, then you can cancel those parentheses. Okay? So we're going to go ahead and factor the top. So you can use your diamond method on the top, and we're going to factor the bottom using the diamond method on the bottom. I don't use the diamond method. It's up to you what you want to do. But remember that this number is like your adding and subtracting number. And this number is your multiplying number. So the only numbers that multiply to be 3 are 1 and 3. So which one would need to be negative in order to make a negative 2 when you're adding? The 3. And always double check. So 1 times negative 3 is negative 3, and 1 plus negative 3 makes a negative 2.
I got it.
So my top is going to factor to be x plus 1 and x minus 3.
Well, I got x plus 1.
Okay, then on the bottom, if there isn't a number, that's really a negative 1. And then we have a negative 6. And again, this is my adding and subtracting number, and this is my multiplying number. So the numbers that multiply to be 6 are 1 and 6 and 2 and 3. Well, 2 and 3 are the ones that will make 1. And in order to make it a negative 1, which one would need to be negative?
3.
The 3. Okay, and always double check. 2 times negative 3 makes negative 6. 2 plus negative 3 makes a negative 1. So my parentheses are x plus 2 and x minus 3. At this point, if you notice anything that is exactly the same, we can cancel them out. So is there anything that's exactly the same? Good. So we'll cancel those out. So now my answer is x plus 1 over x plus 2. And again, remember, we don't know what x is. So anytime you have adding or subtracting something, I cannot cancel these x's out because they're connected with that 1. Okay? And there's a good chance that it wouldn't reduce. Make sense? Yes? All right. Okay, example 2.
So that's your answer?
That's your answer.
Woo-hoo!
Later on. These we're just going to reduce. Okay, factor and then reduce. Okay, so on the top, what would you do first on factoring this?
Take out an x and a 2.
Good, and that is your GCF. So always check for GCF first. In this case, we can take out a 2x, and when I divide this by 2x, I'm left with
x plus 5.
X plus 5. Very good. My denominator, can I take out a GCF?
No.
So when we have a number in front, which method do we use to factor that?
Bottoms up, bottoms up.
Your bottoms up, over, under, whatever you say. So I'm going over by 3.
Under by 5.
We get x squared plus 16x plus 15. So what numbers multiply to be 15 and add to be 16? Good, 15 and 1. 15 and 1 makes 16. And they add to be 16 and multiply to be 15. So I have x plus 15 and x plus 1. Okay? What you have to remember is that whatever number you went over by, that is the same number that you go under by. So I'm going under by 3 to both of these. 15 divided by 3 makes what? 5. This reduces the 5. You always want to reduce if you can. So now one of my parentheses is x plus 5. 1 over 3 can't reduce, and anytime you still have a fraction left, you bring that bottoms up. And so we end up getting 3x plus 1. Are there any like terms on this one? Good, x plus 5. So I'm going to go ahead and cancel out those x plus 5s. And I'm left with 2x over 3x plus 1. Okay, questions so far?
This is two.
All right, example 3. Is there anything I can do at the top? No. I'm going too fast? Okay. So we just have x minus 4 on the top. Over. What do you notice about this one? It's a cube, right? It's not a square. It's a cube. So we have to factor using the cube method. And so first thing you need to do, though, is rewrite 64. Can I write that as a cube? Very good. It is 4 cubed. Okay, who remembers what my first parenthesis is? Yes, so it's whatever it is with the cubes, but you just take the cubes away. So that means it's going to be
X minus 4.
x minus 4 is correct. Okay, so then we have our next parenthesis.
It's up there, guys. It's cube factory.
Yeah, so it's on the wall if you need it. This right here, the first term is the first term squared. So that means it's going to be what? X squared. Who remembers what the middle term is? You multiply those two together. So 4 times x is,
4.
but if this is minus, this is going to be a
Plus.
plus 4x. So it's always the opposite sign. And then your last term is the last term squared. And negative 4 squared gives me a positive 16. Okay? Is there anything that we can or cancel?
Yes.
This doesn't factor further. Okay? So these cancel, and we end up with, if there's nothing on the top, what's actually there? A 1 over x squared plus 4x plus 16. Questions? All right, example 4. What do you do when there are 4 terms?
You do the you take 2, you take 2. You break them in half.
Good, yes. It's called grouping.
I was close enough.
Yeah, you knew what you're doing. So we're grouping the first 2 and the last 2.
Why did you look at me like that?
I didn't. Okay, you take the GCF out of the first group, and what is the GCF out of the first group?
Squared.
Very good. I'm going to write over here. So you have x squared, and what's left? X minus 5. Very good. Okay, in the second group, what am I going to take out? Good. I'm going to take out a negative 3 because I want to end up getting a negative here in the middle, and you want a positive in front. So I'm going to take out a negative 3. When I do that, I'm dividing each of these terms by negative 3. 2 negative 3's, these cancel out, and that makes a positive x left over. And 15 divided by negative 3 makes
Negative 5.
negative 5. The whole purpose is that these parentheses should end up being the same,
Why?
because that's going to end up becoming our GCF. That's what you're taking out.
Oh, yeah, that's right.
Okay?
I remember now.
If these don't match, you did something wrong and you need to go back and fix it. Okay? So these match. This is now my GCF of the problem. So I am taking out an x minus 5. And what's left with, I'm left with there is x squared minus 3. If you could factor this further, you would, but is 3 a square? No, so I can't factor that. Okay, then we're going to go to the denominator. So we're looking at what multiplies to be 15, adds to be negative 8. Good, so we're going to have 3 and 5, okay, but how am I going to make it a negative 8 and a positive 15? Very good, both are negatives. Negative 3 plus negative 5 is negative 8. Negative 3 times negative 5, positive 15. So we have x minus 3 and x minus 5. Is there anything like here that I can end up canceling now? Good, x minus 5. Can I cancel anything here? No, why not? Good, this has an x squared. They have to be exactly the same in order to cancel them. So my answer is x squared minus 3 over x minus 3.
Now say if you were able to cancel all of them.
Then you'd be left with 1. Okay? So, any questions? All right, moving on. Okay, example 8. Can I do anything with the top? No. Okay, on the bottom, can I factor anything out? Okay, so we can take out a GCF of 8. And when I divide, bless you, when I divide each of these by 8, what am I left with? Okay.
That's not right.
Right. Are these exactly the same? No, because here the y is positive, here the y is, here the x is positive, here the x is negative. Now, if I were to take out a negative, so if I would have factored out a negative 8, this would have been negative and this would have been positive. Now look, are these the same? Even though they're not written in the same order, are they the same? Yes, because we have negative y, positive x. So can I cancel those now? Yes. So I'm going to cancel out the x minus y, negative y plus x. If there is nothing on the top, what is there? 1. So it's 1 over negative 8. A lot of people want to just write the answer as negative 8. Be very careful. Don't do that. If there's nothing on the top, this is still a fraction. Okay, the negative 8 stays on the bottom, and then you would just have a 1 on top. Oops. Say that again. So remember when I originally factored this and I took out an 8, I just had y minus x. Y minus x and x minus y are not the same, right? So I was saying here, the y is negative here and positive here. So if you were to take out a negative, so I'm showing if we were to take out a negative, if we had taken out a negative 8 to begin with, the y would have been negative and the x would be positive, and then now they match. X is positive and y is negative, so that we can cancel them out. Because you can only cancel them if they're exactly the same. Is that okay? All right. Okay, example 6. When you have 2 plus x squared, what does that actually mean? It's the same as x plus 2, but when it's squared, that means there are 2 of them. Very good. So let's just write out with 2 of them. 2 plus x times 2 plus x. Okay, over. And then what numbers multiply to be 8 and add to be 6? Very good. X plus 4 and x plus 2. So looking at this one, 2 plus x and x plus 2, are those the same?
Yeah.
Yeah, the x's are both positive, the 2's are both positive. So can I go ahead and cancel those? Yeah. So we can only cancel out 1 for 1 though, right?
Yeah, so you are left with 2 plus x on the top and x plus 4 on the bottom.
Very good. So I have 2 plus x over x plus 4. Now, on your answers, most of the time they will always write x first. So you might see the answer is x plus 2 over x plus 4. They both mean the same thing. Either answer is good. Questions there? All right, now we're moving on to multiplying. Okay. Notice that there are 2 fractions, okay? Whenever you're multiplying fractions, just remember that anything on the top can be reduced with anything on the bottom. So you can cancel up and down, you can cancel side to side. You just can't cancel 2 things that are both on the top, right? One on the top, one on the bottom. Okay.
You can cancel out.
On example 1, do you notice any pluses or minuses? No. So when everything's multiplying, they don't have to be exactly the same. You can cancel out an x for an x and so on. Okay? Now, my suggestion on these problems, because it gets a little confusing, is when you don't have adding and subtracting, simplify it first, then reduce. So what I mean is I would go ahead and multiply and put everything on the top together. So on the top, I'm going to end up with what? Perfect. And then in the denominator, I'm going to have what? 15x to the 4th y. Do you have to do it my way? No. I do it this way because you have a less chance for error and like not seeing which ones that I cancel, which ones are left. I feel like if you simplify it first, you don't make as many errors because you can see everything in one spot
So
instead
you're
of.
left with 1 over.
Okay, so these are like kind of separate problems. You're going to look first at your numbers. Can 5 and 15 reduce? Yes. Okay, so 5 cancels and 5 goes into 15 3 times. Okay, now you have your x problem. I have 3 x's on top, 4 x's on the bottom. So what happens?
The 3's cancel and then there's one left over.
Good. All of them on the top cancel, and then there is just 1 left over on the bottom. What happens with my now y's?
There's 3 on the top.
Good. 1 cancels here, and then we just have 3 y's left on the top. So when we write our answer, on the top we have y to the third, good, or y cubed, and then we have 3x in the denominator. And then always double check, nothing more can reduce. That is my answer. Questions? Okay, example 2. So the not so fun part about some of these examples is that you might have to factor 4 different things this time, okay? So, starting here with the first fraction, can I factor anything here?
Yes, the x's can cancel
You
out.
can take it at 3.
I can take out a 3. I can't cancel out x's because there's pluses and minuses right now, right? Anytime you have a plus or minus, you can't cancel it unless the whole thing is exactly the same as something else. So we can take out a 3, and I'm left with x minus 4. The bottom fraction there, can I cancel or reduce any, or can I factor anything?
No.
Well, not on the first part.
Okay, so we just have x plus 5. Okay, times. X plus 6, can't factor, so I rewrite x plus 6. And on the bottom, can I do anything? We can take out a 2, and I'm left with,
X minus 4. So the x minus 4 cancel out.
that is correct. So the x minus 4s can cancel out. Can anything else reduce?
No, but I
No.
forgot the answer.
So you're going to write the answer as 3 parenthesis x plus 6 because that's everything that's left on the top, divided by, and on the bottom you're going to always put the number. If there's like a number or an x or a single term, that goes out in front. So the 2 is going to go in front, and then we have x plus 5 left in parentheses. And then always just double check, because sometimes you might not see something when they're all separate, but when you put it together you might notice, oh wait, I could have reduced that. But we can't here, you're going to leave your answer like that.
Can you distribute the simplified one?
You could distribute, but it's actually more simplified having it factored. Okay? All right, moving on.
Oh my
So
god.
it's just how it's-
All right, so example 3. Notice there's a little bit more to factor here. Okay, so starting on the first fraction, we are looking for something that adds to be 5 and multiplies to be negative 36. So what numbers can work there? Okay, so we have 9 and 4. In order to make a positive 5, what are we going to make negative? The 4, negative 4. So we have x plus 9 and x minus 4. Okay, my denominator of the first fraction, what is that going to be? Good. 49 is really 7 squared, so we have a difference of 2 squares. So we get x plus 7 and x minus 7 times. Okay, the top over here, we are looking for what adds to be negative 11, what multiplies to be 28. Good. Negative 7 and negative 4. Okay? Those multiply to make a positive 28, and when you add them, it makes a negative 11. So we have x minus 7 and x minus 4.
I feel bad for that, but
So we have our 1 still in the denominator.
I feel bad for the next class only because it's so long.
What, is there anything on the top that's exactly the same as something on the bottom?
Yes, ma'am.
X minus 7s. Good. Do we notice anything else?
No.
So we're going to write our answer.
It's
I have x plus 9. If I have 2 of the same thing, how will I write that?
squared.
So I'm going to write x minus 4 squared over
X plus 7.
x plus 7. And that's your answer.
This is too easy. Just kidding.
How much do we buy?
Okay. Are we good here? Yes? Okay, moving on to dividing fractions. Who remembers the thing that you need to remember with dividing fractions?
You subtract x.
Kelsey.
You put the second one and multiply.
Yes. So you never actually divide fractions. You end up changing it to multiplication and flipping it. Some of you might have learned it as KFC. Does that sound familiar? Keep, flip, change. Okay? So you always want to keep the first one the same. You flip the second fraction, and then you change your division sign to multiplication. Okay? So keep this one, flip this one, change that sign to multiplication. So we don't actually divide fractions. So we're going to go ahead and rewrite this.
Then why does it say divide?
We're going to change division to multiplication. So you have to do that extra step. Okay?
Which is easy.
Yes. So we're going to rewrite this. 5x squared y to the third over x to the seventh times, and then we have y to the third over 30x y to the fourth.
On this one, is this where you do, is this where you, subtract the exponents?
Yes, when you reduce, yes. Okay, so like I said before, when we are multiplying fractions like this, simplify them first. Okay, so on the top I'm going to end up with 5. Good, x squared and y to the sixth. Oops. And the denominator. Good, 30x to the eighth, y to the fourth. And then we will go through and reduce. It looks like it's unplugged. Okay. So, 5 over 30. Let me give you a minute. Go ahead and try reducing it.
It's so hard to put in there. How do you do it? Your arm is strong like that or what?
Yes. Okay, so 5 and 30, how do those reduce? 1 over 6. The x squared and the x to the eighth. X squareds cancel, and this becomes a x to the sixth. Here we have 6 up here, so these 4 cancel, and this 6 becomes a 2. So on the top, I'm left with y squared over, and that is my answer.
Okay. I'm too tired.
All right. Example 2. Now, since we have all of this dividing, I wouldn't rewrite it first. I would do factoring and flipping all at the same time. Okay? So, on my first fraction, what adds to be negative 6 and multiplies to be negative 27? Good. A negative 9 and a positive 3. Those add to make negative 6, multiply to be negative 27. So we have x minus 9, x plus 3. And the denominator there, what could I factor out? Good. So we take out a 2x, and I'm left with x plus 1. What do we do with our division sign? Change it to multiplication. And when I change that to multiplication, what do I end up doing with this fraction? Flipping it. So this x squared is going to end up going to the top. And then we need to figure out for the denominator what multiplies to be 45 and adds to be negative 14. Very good. Negative 9 and negative 5. Those add to be negative 14, multiply to be a positive 45. X minus 9, x minus 5.
That's pretty easy.
What can reduce?
X minus 9.
Very good. This x squared and this 2x. See how there's no adding and subtracting there? It's just the 2x, and this is just x squared. 1x here can reduce with one of the x's on the top, so just making that an x. Anything else we notice?
No.
Okay, so we always bring the terms that are like single to the front, and so I have x times x plus 3 over, and in the denominator, what am I going to have?
2x minus 5.
2x plus 1 and x minus 5.
I wrote 2x's again.
And that is my answer.